Welcome to section 2.4, arc length and surface area. This is going to be a short and simple section, so I hope you'll all appreciate that. In this box, I have the formula for arc length, and sometimes you will see this written as, instead of f prime squared underneath the square root, it will be y prime squared, but those are the same thing. So let's use that formula to find the arc length of 2x to the 3 halves over the interval of x equal 1 to 2. So we're going to start by finding y prime, and that's 3x to the 1 half. And so this implies that y prime squared is 9x. So the arc length L is the integral from x equal 1 to x equal 2, that's given in the problem, of the square root of 1 plus y prime squared, which is 9x, dx. Okay, that's a u sub. U equal 1 plus 9x. Du is 9 dx. I need to divide both sides by 9. 1/9 du is dx. So L is 1/9 the integral du. What's left is u to the 1 half, and we'll change our limits. When x is 1, u is 10, and when x is 2, u is 19. So this is 1/9 times 2/3 u to the 3 halves, evaluated between 10 and 19, which is 2 over 27, and then 19 to the 3 halves minus 10 to the 3 halves. And that's, in terms of simplification, that's as far as I can go without using a calculator. Okay, here I have the formulas for surface area for a surface of revolution. And you don't have to memorize these formulas because we simply won't use them enough for you to memorize them. We're going to use this one because we're going to do an example where we're revolving around the x-axis. It looks a lot like the arc length formula, except there's an f of x and a 2 pi there that's extra. All right, so here's our example. Again, we start by finding y prime. That's 3 halves x to the negative 1 half. Let me write that as a fraction, 3 over 2 root x. So this implies that y prime quantity squared is 9 over 4x. Now in the formula you see an f of x and I'm writing y, but of course y is f of x. They're interchangeable. All right, so the surface area is 2 pi. I'm going to pull that out. Integral, x goes from 3 to 4. F of x is 3 root x. And then I've got root of 1 plus 9 over 4x dx. Okay, well, let's pull our constants out front. That's 6 pi integral from 3 to 4. Let's combine these two square roots. Using square root of a times the square root of b is the square root of ab. So this is 1 square root, and I have x plus 9 over 4 dx. So again, it's a u sub. U equals x plus 9 over 4. Du is simply dx, no modification necessary. So we've got 6 pi integral of u to the 1 half du. And now our limits, when x is 3, u is 21 over 4. And when x is 4, u is 25 over 4. And so this is 6 pi, 2/3 u to the 3 halves between those two limits. All right, well, that gives us 4 pi as our constant. And then when I put 25 over 4 in for u, I get 25 over 4 to the 3 halves. And then it's going to be minus 21 over 4 to the 3 halves. Okay, and let's just have some fun with this. Let's take it as far as we can without using a calculator. So this is 4 pi. 25 over 4 to the 3 halves we can do without a calculator. That's 125 over 8. And then 21 to the 3 halves we're going to leave as it is. But the denominator, 4 to the 3 halves, we can do. That's 8. So now pull the 8 out and we get pi over 2. 125 minus 21 to the 3 halves. And that truly is as far as I can take it without a calculator. Okay, and that's the end of this section.